Hello, in this tutorial I will be explaining how to perform split and combine analysis in order to assure best output quality for sample group comparisons. Proportional variation between midcuts can cause error in the sample alignment within the full data matrix, meaning that the groups are not always exactly aligned region to region. The regions can however be realigned with user inputs or with border regions detected by LAM. This is done by splitting projected datasets with the companion script splitdatasets.py, then performing projection on the subsets, and then recombining the sets with combined_sets.py to provide a dataset where each subset is aligned. The first step is to perform projection and border detection on the full dataset with LAM's count option, while using anchoring points at R3 region to reduce initial error. Width approximation and feature-to-feature calculations on the vector channel must also be selected, as they are required by the border detection. The border detection algorithm creates a file, borders_peaks.csv, that contains bin locations of detected borders for each sample. These bins can be used to cut the samples, but the cutting can also be performed using projectable points that are given as input to each sample, similarly to an anchoring point. Using the border peak plot as assistance, corresponding borders can be selected from each sample group to create a file containing the split locations for each sample. The file should have samples on columns and each corresponding split point on rows. Note that each sample must have value at each cut point. The path to this file must be given to the split dataset script. The script file contains extended instructions, but in short, it must be provided with path to the analysis directory, path to where the resulting subsets are to be saved, the names of the cut points in order from beginning to end, what channels to split, and the wanted number of bins for the final combined dataset. The cont_end variable controls if the segment after the final cut point is included. If using a cut point file, the sample bins variable must be true, and bin path must point to the file containing the cut points. The row labels in the file must be named the same as the ones given in the cut points variable. After executing the script, the subsets need to be projected again to rebin the data. The script outputs direction giving recommendations on bin numbers for the subsets based on their vector length fraction. For the combined script, you only need to perform the count option for each subset in order to project and bin the data again. You can run each of the subsets consecutively from the GUI, but the easiest way is to create a batch file that performs the analysis without user input. The specific commands in the batch file depend on your default settings. Here, I command LAM to only perform the count option and to turn everything else off, including dialog. Additionally, after using the split script, the data header row value must be set to 0. Once the subsets have been counted, they can be combined using the combined_sets.py companion script. The script must be provided with the paths to the subsets, their bin numbers, the channels to combine, and finally, the output path. Once these are set, the script can be executed. As a result, the projected subsets are merged into a full dataset that can be analyzed as one. It is important that when LAM analysis is performed for the combined dataset, the count option must be performed without projection, in order to retain the projections based on the earlier subsets. If projection would be set to true, the data would be rebinned again and the regionalized binning would be lost. The combined dataset can be subjected to any of LAM's functionalities. The output of the resulting data analysis will have reduced error rates between the sample groups due to better biological correspondence of regions thanks to the split and combine method.